Box, label A, slides across checkout upside down. The scanner still returns the same 12 digits. Not a picture of a number, a direction-finding machine printed in ink. The long bars at the edges feel like arrows. They are not arrows. The trick is buried inside the digits themselves, where the left half and right half use different parity languages. A human sees stripes. The scanner sees a sequence of widths. So the question is not what product this is, it is how the symbol tells the scanner which end it entered. Box label A has printed numerals underneath. Those are for humans. The machine reads the dark and light bands above them, then converts their relative widths into symbol characters. Even the empty white space is engineered. UPC-A requires a 9-module quiet zone on each side. Like shoulders on a narrow road, that blank margin separates signal from packaging noise. The obvious answer is that the scanner recognizes the barcode shape, like matching a logo. Then a database returns the product. That explanation is reasonable, and it is wrong in the important way. Inside the margins, UPC-A is a 95-module machine. With the quiet zones included, it spans 113 modules. That is, the difference between measuring the road and measuring the road plus shoulders. 3 guard patterns cut that machine into lanes. The ends are 3 modules each. The center is 5. Together, they are 11 modules of overhead, lane dividers, not cargo. The real question is, what happens after an edge guard? The guard at either end has the same pattern. So the first useful clue cannot be the edge. It has to be the digits that follow. Every data digit occupies 7 modules. 6 digits fill the left half, 42 modules. 6 more fill the right half, another 42. Equal chambers on opposite sides of the center guard. Each 7-module digit contains 4 elements, a pair of dark bars and a pair of light spaces. Each element may be 1, 2, 3, or 4 modules wide, short through longest. That is why the scanner does not need a perfect photograph. It measures transitions from light to dark, then fits them back onto the module grid. The unit is width, not artwork. Now, direction enters the system. UPC-A writes the left side digits in number set A. GS1 defines that set as odd parity. The dark bar total is odd, like an internal left side accent. The right side speaks differently. UPC-A writes those digits in number set C. GS1 defines set C as even parity, the opposite accent from the left half. Take digit 0. On the left, its encoded bars and spaces come from set A. On the right, the same value comes from set C. Same digit, different dialect. This solves the edge problem. Both outside guards are the same 3-module pattern. A scanner entering from either side sees a familiar doorway, then asks which parity language comes next. When box label A is crossed from the normal left side, the first 6 data characters are odd parity. That is a full half of evidence. Odd first means the decoded order is already forward. Cross the same label from the other end. The first 6 decoded data characters are even parity. Microsoft Press describes that clue as enough for software to know it is reading right to left, then reverse the data. The center guard is the hinge. It is 5 modules wide, separating the 2 42-module halves. After that hinge, the parity language must change. By now, the scanner has not identified a product. It has only assembled an ordered string of 12 digits. Parity answered direction. A separate test still has to answer trust. The last digit is not a direction arrow, it is a check digit. GS1's calculation tests the complete 12-digit string after the scanner has put the digits in order. The weights alternate 3 and 1 across the 12 positions. 6 positions are heavy, 6 are light. Like a metronome, the pattern makes the same digit count differently depending on where it lands. After multiplying and adding, the result must land on the 10-step cycle correctly. Cornell gives the clean form. The weighted dot product must equal 0 modulo 10. A turnstile, not a lookup. Change a single digit and the widths can still decode, but the arithmetic fails. A JTech paper reports 100% single-digit error detection for UPC modulus 10. The scan becomes a stop sign. That is the larger lesson behind box label A. The symbol carries its own reading instructions, margins, guards, parity, and checksum, not intelligence. Redundancy stacked in the right order. The protection has limits. Cornell shows adjacent swaps fail when the 2 digits differ by 5. That is halfway around the 10-digit wheel, a narrow gap left open by the math. That trade-off buys speed at checkout. GS1 lists EAN UPC as omnidirectionally decodable. A cashier does not have to aim the package perfectly because the symbol says how it was crossed. The printed number is the product identifier. The black lines are the machine that protects it. A barcode is not read backward by luck. It is written to survive being read backward. There's a hidden system behind almost everything. Subscribe and we'll find the next one.